Alright, hello everyone. Today is the final video of the advent calendar, and yeah, today is not a maths video, although it's maths related. Um, yeah, uh, Today I'm going to be talking about, I'm beginning what I hope will be a termly series, so I'll update this, I'll do a video like this every term, unless you guys hate it, in which case I won't, but okay. In which I just go through my notebooks. Because I think that's quite an interesting way to get an insight of what someone's been learning. You just look at what they've written down. Um, and so yeah, today, I've first year, first term doing at Cambridge doing maths, and I've got 3 notebooks to go through, so we'll go through them. And yeah, I'm pretty sure if I show any of the stuff in the notebooks, it'll all be backwards anyway. So don't expect me to point out specific equations and stuff, get really technical into what I was writing. This is just sort of supposed to give you an insight into the topics that I've been learning at Cambridge and in my own time. And yeah, just another perspective on what it's like studying maths at Cambridge. So, and just, into my personal, if you're a Gregorious maths fan instead of just someone curious about Cambridge, into my notebooks, into how I have been doing. So, okay, the first notebook is this one here. So this is a notebook. This is an old notebook. I probably got this like 3-4 years ago. So if we actually start this notebook, none of this is what I've learned at Cambridge. So this is a differential forms. I was making notes on differential forms. This is ages ago. And these are really neat notes. If you look at this, I don't know if you can read anything, but this is really neat, especially by my standards. You'll see as the video goes on. Now, I was making notes from, I believe the guy's called Michael Penn. You know, he's a big YouTuber. I was making notes on his videos. And yeah, let's have a look. So what was I doing? I was wedge products. What is a one form? What is dx wedge dy? What else was there going into? I remember learning about learning about u substitution, but in general. So like the Jacobian and stuff. And how you can generalize that with differential forms. Here we have some notes on category theory. Not right here on not what exactly was I talking about? Oh, pre-sheaves and stuff. Yeah, sure, okay. And then we have a proof that Louisville numbers are transcendental. Yeah, these are all old notes, by the way. These are probably a couple of years before coming to uni. I have some notes from a stable homotopy theory lecture. Yeah, no idea when this was, but these are also pretty neat. I think I dedicated this book as being like a neat notebook. Yeah, this was lecture 1 of some series. And then what do we have here? We just have some random trig functions written everywhere. No idea where this is from. Yeah, got a lot of working out here. This might be, yeah, before I came, actually, I don't know this might just be A-level stuff. This is all boring stuff. Some partial fractions going on here, some differential equations. Yeah, no, actually, I believe what this is this stuff here. You can see, okay, this is pretty all elementary stuff, like partial fractions, some differential, first order DEs, like separable or whatever. Before I came to Cambridge, we got set a problem sheet with A-level questions for the non-British viewers out there. That's end of high school, level. So integration on, e to the x or whatever. Stuff like that. with a bunch of like like not difficult, just like to make sure that you're like not bad at maths or whatever. Um, so yeah, this is a bunch of it was really long. I had also no, I didn't have all summer. I had like a month in the summer holiday to do it, and for some reason I decided uh I wouldn't do it then. So I ended up doing loads of work like in my first day at Cambridge or something, just because they wanted us to submit it as soon as we got to Cambridge. And when I had arrived at Cambridge, I was nowhere near finishing the sheet. So yeah, that kind of ruined like my first 2 days at Cambridge. I just had to finish this sheet, which was kind of annoying, but it was like entirely my fault because I had the whole month to do it, and it just looked so boring that like I didn't want to do it. But yeah, eventually, like the anxiety of not wanting to be the guy who his very first assignment is turned in like late outweighed the boredom or like the elementariness of the assignment. There was also actually there was two other questions. One was on stereographic projection, which was somewhat interesting. I don't know why they said us that though, because we haven't done anything with stereographic projection since. Oh no, maybe we have. I think it was meant to be an intro to the Mobius group, which is we learn about that in group theory at the end. Yeah, that was probably why they set that. Um, and then there was also one on the symmetries of a cube where they introduced the orbit stabilizer theorem, and that was actually quite nice. So yeah, those two questions at the end were nice, but apart from that, it was all basic stuff, just to make sure that you know you're not behind or like before joining. I think. Okay, now we get into some notes. So here's notes from when I was actually at Cambridge. Um, so yeah, the course is split up into 4 modules in the first term, half pure, half applied. The pure ones are numbers and sets and groups, and then the applied ones are vectors and matrices and differential equations. So yeah, we have some notes here from numbers and sets, where this is like the very first lecture I went to. Yeah, you can take a look. You can pause if you want. I don't know if you can read that, but it's still like basic stuff so far. It's like the first lecture. The start of vectors and matrices, we just looked at like complex numbers and stuff, like adding them, like stuff like that. Then differential equations, we started by doing calculus, um, and big O and little O notation as well. Yeah, you can see some notes on big O and little O notation somewhere around here. Then what do we have next? Yeah, we have groups. So we start groups by looking at symmetries. So we think of it as symmetries. We looked at the symmetries of a triangle, show that like, if you can look at those as a group, like you compose two symmetries, you get another one. Each symmetry has an inverse, that type of thing. And then we went on to actually define a group. Now we're back to DEs, doing more calculus. So yeah, the first week or two of lectures is not hard. It's mostly, I mean, with groups, it's not stuff that we've learned in school, but it's not. They don't plunge you straight into the deep end. They ease you in sort of. So yeah, groups are just more random stuff. Numbers and sets. We're talking here about functions. What else are we talking? Yeah, I didn't make many notes from that lecture. V and M. This is when we define the vector space, and the projection of B onto a inner product, what that is. Okay, let me skip forward a little bit. Vectors and matrices, talking now about the Cauchy-Schwarz inequality, triangle inequality. Then we looked at the cross product. That was quite a big thing. We looked at the scalar triple product as well. Yeah, this was all new to me. No, not all of it was new to me, but this was actually somewhat interesting to me. Just because I'd never bothered like really looking into what was going on there before. So that was nice. And then we looked at like the equations of lines and planes and stuff. And then in D's, we finally started looking at partial differentiation. And we looked at the integration underneath the differentiation underneath the integral sign. Um, and we actually showed that the gamma function is m minus 1 factorial, as an example, which is nice. Oh yes, then here in groups, we start talking about the dihedral group. We spent quite a lot of time talking about the dihedral group. I've got quite a lot of notes on that, actually. What did we show? We showed that it has size 2n, you know, that type of thing. And when we proved the dihedral relation. And then in numbers and sets, we talked about the Peano axioms. Fair enough, that seems about right. Vectors and matrices, more stuff on the cross product, and also like solving vector equations. Here, like if you look here, you go here. Then we looked at the Levi-Civita symbol, which is quite important, and the Einstein summation notation, which was kind of weird at first, but I mean, once I'd used it in exercises, it was, well, I mean, you find that it's actually like really helpful. You just need to get used to it, basically. Oh yeah, in numbers and sets, we looked at the induction, like well ordering principle and stuff. Here I have my working out. Right, okay. Here you have like just me writing random working out. Still looks decently neat. So at the back of the notebook, I did working out on exercises. This is just some like random numbers and set stuff, I think. Oh, there was some question where like they define this right here. There was some question where they defined some like function by like a recurrence relation, and they wanted you to figure out 5 star 5, where like this star was like this operation, whatever. And like, here, this is my attempt on like working it out by hand. But it's a good thing I didn't continue, because the end result ended up being like some crazy huge number, like 2 to the 2 to the 2 to the, like some massive number. So yeah, I would still be doing that question if I tried to work it out by hand, basically. That was quite mean. Yeah, here we have some differential equations work, where it's basically calculus. I shouldn't say differential equations when it's calculus at this stage, but it was the first sheet on differential equations was just calculus. Then we have some working out on groups, and at the very back we have some notes on the Mobius group. So you can see my notes on the Mobius group. This was, I mean, I pretty much outlined all of this in my video on the Mobius group, where I just say like some basic thoughts. Like I just wanted to know what the Mobius group was, basically. So yeah, this was like right at the start of term. I made these notes because I was curious. And then at the very end, you have also some non-Cambridge stuff. This is just this is actually my working out when I was doing like TMUA papers, TMUA. It's like a entrance exam for some UK universities. You can see I was just doing some random working out here. I didn't do very well on the TMUA actually, so yeah, I don't want to look at this. But yeah, I think the rest of this book is just working out for TMUA papers. So yeah, that concludes the first notebook. So this notebook is like mostly Cambridge stuff, but at the beginning and at the end you have old stuff, like the differential form stuff, that's all old. But yeah, that's this notebook. Now, here we have this notebook, okay? This I got from Tesco's while I was already at Cambridge. Once I'd finished that old notebook, I needed a new notebook, so I went and bought this. This notebook is huge. It's very thick. It's like 300 pages here. And okay, I have 2 notebooks here, right? Okay. The only difference you can see is this one has a shaded in A and this one doesn't. That's how I distinguish between the two. The one with the shaded in A is like for Cambridge stuff. Or it's for exercises basically. Problem sheets. So we get set problem sheets. You have to do like one every 2 weeks for each module. So you're doing 4 every 2 weeks. And those problem sheets are hard. Like they're hard, you know. As much as I like to think I understand the content that's being taught, like it doesn't mean that the problems still can't be difficult. Like, you know, they some of them take me ages, you know. So yeah. In this notebook, okay, first things first, actually, something that you Gregorious maths fans might find interesting. I have started this book with a list of video ideas, and on this list, we have what's some that I have done. Cayley's theorem follows from Unada. I did that. Faithful actions are just faithful functors. I did that. Inside the notebooks of a Cambridge math student. You're currently watching that. A deeper look at the first isomorphism theorem. I did that in my advent calendar. And I have quite a few interesting ones here that I would want to do later on. So stay tuned. But some of these are like absolute duds. Some of these I'm never doing. But most of these are actually interesting. So yeah, I've got a list of video ideas here because otherwise, like half of these I would have completely forgotten about. So I'm glad I started that list. So yeah, okay, here we just have me doing a bunch of exercises. So for example, when I had to do like some exercises on the Einstein summation notation, you can see here, like I'm probably getting, probably what you're reading here is wrong somehow. You know, because I kept on forgetting like to not let there be 3 indices or whatever, blah blah blah, you know, just like breaking all the rules, you know, as soon as it got remotely complicated. But I'm really glad that I did these exercises because I like to think that I sort of get it now. Like I can really do it now. Yeah, we have more Einstein summation notation work here. What else do we have? Group actions were a big thing at some point. And some questions about isometries as well. I have no idea. I sort of remember this. There's some really long, annoying questions in vectors and matrices. I think the start of this book, I was doing 2 sheets at once. I was like doing groups until I got bored with that, and then I would switch to VNM, and then I would switch back to groups and so on. Yeah, but some of the vectors and matrices questions are just long. Like they're just annoying, you know. Okay, here we have some numbers and sets working out. Here you can see, for example, I was doing like Euclid's algorithm on something for whatever reason. I don't remember why, but I was doing that. And there's some stuff on n choose r, like permutations and stuff. This is somehow not just get an idea, right? Some of this working is like a little bit messy. This is me trying to figure out something in numbers and sets, and I can't even tell what it was anymore. But yeah, like sometimes the working out just gets like that, you know. Yes, finally solving differential equations in DEs, which is nice. Yeah, like look at this page here. Like I don't know what half of this is anymore, but let me have a look. Yeah, it's just like first order differential equations or something. Oh yeah, there was a question on Newton's law of cooling, and I didn't know what Newton's law of cooling was. I had to look it up. I made a note here, like with a sad face. I don't know if you can read it, but I basically wrote Newton's law of cooling equals sad face. Finding out half-lives equals sad face. Because there was another question on half-lives, and I was like, okay, I haven't done science. I haven't done this in years. Like, what even is going on? Yeah, I had to look up like the formulas and stuff, which is kind of a pain. Yeah. Yeah, let's keep going. Oh yeah, we had to. Oh yeah, yeah, yeah. Look, we have to sketch some stuff. We had to like draw like isoclines and whatever. That I did not enjoy. Yeah, that was kind of tedious. Although, I mean, once I started getting into a bit of a flow state, because there were loads of examples that you had to sketch, but once I started actually like just getting on with it and sketching them, you know, I can sort of see why it's satisfying. Let's put it like that. This is rotations, you absolute donut. Okay, I got angry at myself here. Somehow I did something wrong. I called myself a donut. I don't know. I think I had to find out some conjugacy class in a group sheet, and I spent all this time working it out, and I was getting the wrong answer, and then I realized I was working out the wrong conjugacy class the whole time. Yeah, so I got angry. I let myself have it. Here we have at the very top here. This is me like counting down like what sheets I have to do, because I feel like I think at this point I was starting to think, okay, there's actually quite a lot of work. Like I'm just gonna physically like count like how much I have left to do. Okay, now we have more vectors and matrices stuff. Here I was computing determinants using row operations. Nice. Ah, here we go. Yes, eigenvalues. Lots of stuff on eigenvalues at the end. You can probably see I'm just computing random eigenvalues here. Yeah. Yeah. This can be kind of long, but the good news is it's not too complicated. So you can just compute them, and it's not too difficult. It's just annoying sometimes to compute eigenvalues. Then we have some numbers and sets. Numbers and sets. I'm terrible at numbers and sets because like I've always been bad at competition maths, and I think numbers and sets questions are the most similar to competition maths out of the four modules. So it's always like it always gives me issues. So okay, this is like stuff on like congruences using Fermat's little theorem and stuff. This question here, I actually nicked this question for my first advent calendar video, the video on 5n. Yeah, like with the divisors and stuff. That was a question from one of my sheets. um, yeah, but lots of stuff on like congruences and like divisibility and stuff. Ah, yes. Um, but at the end of numbers and sets, you sort of start doing analysis. Like you start like learning about sequences and what it means for a sequence to converge to something. And this equation here, for all epsilon, there exists an n in the natural numbers such that for blah blah blah. This one here, the definition of convergence, basically. Um, that gave me some nostalgia. I felt the need to like put it in a box and give it a heart because, yeah, it brought me right back to when I was like 13, maybe even 12, but like let's just say 13. Watching Thematica for the first time, and it was some like topology video. It was probably his first topology video on like open sets or something. And I remember watching it, and I was looking at these symbols that he was using, like the there exists sign, after just looking at calculus before, and he was talking about like some for all there exists, and I was like, what on earth? This is so cool. Like he's speaking a whole different language. Like these symbols are crazy. Where are these? Why have I not learned these symbols before? And like I remember I went into English one time in year 8, so yeah, like 12, 13, and they asked us to describe a poem, and I used like this mathematical notation. I was like, for all poems there exists like beauty or something. Yeah. And like writing this definition out just brought me right back to those times where like I thought using the for all symbol was so cool. Like there exists. Uh, yeah, that was great. Yeah, um, yeah, that was something in numbers and sets anyway. We do like convergence of sequences and stuff. Then solving characteristic equations. We also solve difference equations as well. Um, yeah, more difference equations stuff. Then just some random differential equation they wanted us to solve. Then we're back to group theory. This is group sheet 3, which is like meant to be somewhat infamous for being like the hardest sheet in the first term of Cambridge. It was decently hard, but it wasn't like crazy, like, oh my days, I'm spending 12 hours a day and I'm making no progress. But it was hard, but like it wasn't crazy, you know what I mean? But yeah, this is group sheet 3. The topics covered like orbit stabilizer theorem, so group actions in general, first isomorphism theorem as well, that was just covered, quotient groups, stuff like that. And they did make it quite hard, to be fair. Oh yeah, permutation groups as well. We started looking at like what was actually going on. That was enlightening because I mean I looked at permutation groups, but I never, because it looked kind of dry. Like I didn't really care, to be perfectly frank. So obviously doing it at uni forced me to learn what was actually going on. No, it was actually somewhat interesting. Like I don't know why I avoided it this whole time. Like composing permutations and stuff, and like the order of a permutation and whatever. So that was somewhat interesting. And actually, one of these exercises, I think it was question 1, inspired my video. Do you really know what's happening with the first isomorphism theorem or something? Because I was doing the exercise, and then as I was doing it, I was thinking, oh, what the... this is crazy. This is nuts. I never knew this is what the first isomorphism theorem was about. So, yeah. Sometimes stuff like that just happens when you're doing these exercises. So that brings us to the close of groups 3. The final stuff I have in here is probably vectors and matrices 4, which was just quite a bashy sheet. You just need to compute some eigenvalues, you know, see when something's diagonalizable or not. If it is, diagonalize it, that type of thing. That's about everything I have in this notebook. So this notebook is like exercises. So those are the types of things. This is like the notebook that I'll be using like 80% of the time in my first term at Cambridge, where I'm just doing problems and like writing whatever nonsense comes to my mind. So yeah, I didn't want to show too much of like the actual maths in there, but yeah, hopefully you get an idea of like the types of problems that I do. And yeah, this notebook probably provides the most insight into what someone learns in their first term at Cambridge doing maths. Now, this book here, this is like, I dedicated this to like anything that was not a problem sheet, basically. So let's just like dive in. I don't think there's a lot in here this term, at least. There's some notes. I sort of stopped taking notes after a while because I didn't really want to take notes anymore. So there's like a couple of notes. Like there's something on Cayley's theorem. We learned Cayley's theorem, which is actually a nice one. But yeah, there's not a lot of notes in here. I have my notes on why faithful functors are faithful actions. So if you watch the video, basically this. I was just writing it out to like make sure I knew what was going on. I have some notes on the Yoneda dilemma for whatever reason. Ah, yes. I think it's because I was trying to work out why the Yoneda dilemma implies Cayley's theorem. That took me a while to get my head around. Yeah, eventually I did. I made a video on it, but it took me a while. I mean, there's not that many notes, but it's not really reflected in the notebook, but it took me a while to like see what was happening. Then we have, oh yeah, I took notes on eigenvalues and eigenvectors, just because they were important, so I actually took notes for that. I have some work here on entanglement cohomology right here. I think this is all fruitless, but yeah, you can see I was thinking about it at some point. um, yeah, I don't think anything came of this work, but yeah, I was just trying to see if an exact sequence was like actually exact, and it turns out I was talking nonsense the whole time, so I have to like scrap everything and like start again at some point. But yeah, so that was me making that devastating discovery. And now I have some interview questions. So I did a mock interview. These are really neat, actually. Um, yeah, you can see how neat this is because I wanted to read off this like as I was giving the mock interview. So yeah. Let's see. Some of the questions I had were like sketch y equals x to the cos x. Um, integrate Linux was just the first part. It was like show some inequality to do with learn. I was talking about Weierstrass substitution, that type of thing, and hence integrate some trig integral that can be integrated with Weierstrass substitution. And then I ask him, can you think of another way to do this integral? That type of thing. And then I have some notes on the snake lemma. Yeah, this is a potential video actually, so I won't talk too much about this. Something on the interesting about the snake lemma. Keep your eyes peeled. And yeah, I really don't have that much in this notebook from this term. Next term, I plan to actually take notes from the lectures, which you'll all be able to dive into next term. So yeah, I might switch to the notebook I was showing you before for exercises, this notebook for notes, and then a third notebook for like my random endeavors, the non-Cambridge related but maths related. But yeah, I mean, yeah, I didn't put too much planning into like the structure of the video. I just thought, I'll just go through the notebooks. Hopefully you found this somewhat interesting. I did waffle on for quite a while, so apologies for that. But if you're still here, then thank you. I appreciate that. And yeah, hopefully you found this interesting. Give me some feedback. How can I improve this for next term if you want me to do this next term? But otherwise, yeah, I'll see you tomorrow for the 6th anniversary of Gregorious Maths. And in any other case, hopefully in 2026 or end of 2025, but mainly I'm talking about 2026 here. I'll see you more often than I did in 25. Like I had 10 months off, which was inexcusable. But yeah, I plan to upload a lot more regularly. So hopefully you'll be hearing and seeing a lot more of me in the future. And yeah, thanks for watching. Bye.